Okay, let's start it up. These theorems are still in play. I know we're done with Unit 2, but these still are going to be around all year, including today. All right, so let's not forget about them. That's why they're out in front of you. The only thing that's going to change from our proofs from Unit 2 is now you're probably going to see parallel lines imply a new type of angle here. Okay, so let's start with number 1. I'm doing a little something different to introduce this. I'm going to give you all the statements, and I need your help with the reasons why. So first is mark your diagram. How did we mark lines parallel yesterday, and how we're going to keep doing it today? How do we mark lines parallel? For tests, how do we mark them parallel? On a diagram. I should have been more. How do I mark A and B parallel on my diagram? Or we got to, not hash marks. We got to put what with them from yesterday? Arrows. Arrows? What were you going to call them? I don't know. Okay. Arrows. Now, that's on A and B. What should I put on C and D? It doesn't matter. Like, do you want to put 2? That's fine. If you want to put them going up like this, we understand that those are the lines that are parallel. It's up to you. All right, here we go. First statement, y is 3 supplementary to 2. Look at those angles in the diagram, 3 and 2. Can you name what type of angles those are from yesterday? 3 and 2. Look where they are. Start thinking interior, exterior, alternate, same side. What type of angles are 3 and 2 here from yesterday? You got this. 1, 6, 1, 3. Jonathan, remember what those were called from yesterday? 3 and 2 are what type of angles? Same side, interior, and they were supplementary. Everyone, yes? Okay, so what am I going to write? This is why it was such a pain yesterday, because it becomes easy today. How do I start this out? How did I start out all your justifications yesterday? Parallel lines. Arrow imply. Jonathan, what'd you just call them? Same side. Interior angles. And then what do we know about them? Well, we're saying they're what? Are supplementary. Yep. All right, so we got 3 and 2 supplementary. All right, step 3. Now I'm saying 1 and 2 are supplementary. Why? 1 and 2 are supplementary. Why am I saying that now? What type of angles are 1 and 2 up here? Don't overthink it. 1, 8. Lily?
Just straight angles.
Oh. I need something with parallel lines.
Okay.
Look where they are. Inside or outside?
Interior.
And are they on the same side or alternate? 1 and 2. 1 and 2.
Oh.
Are they on the same side?
Same side.
So put them together. They're what?
Same side, interior.
The same thing, right? They're the same thing as 3 and 2. Parallel lines imply same side. Interior angles are supplementary. All right, now why were 1 and 3 congruent? And again, 1 and 3 are not going to be congruent because they're alternate interior, same side exterior. They're going to be congruent because of something we've already used. All right, take a look at steps 2 and 3. We wrote those down for a reason. 3 is supplementary to 2. 1 is supplementary to 2. Why are 1 and 3 both congruent then? Look on your sheet, please. Talk it over with your group. I'll give you about 30 seconds to decide why they're congruent. And it has nothing to do with parallel lines. Nothing. Nothing to do with parallel lines. We're going back to last unit now.
Well, because there's 2. Yeah, both supplements.
Any group confident why they're congruent? Lexi, your group. 1 and 3 are congruent because 1 and 3 are supplementary to the same angle. And last unit we said if that happens, they are congruent. So yes, supplements of the same angle are congruent. This is where we start meshing everything together now. This unit with everything we've done this year. I didn't hear it in here, but I heard it in my first period class. Substitution. Substitution. Hey, look. Substitution only works if the angles are equal to each other. Substitution does not work with supplementary angles. Okay, so just get substitution. I get it why that would happen, but substitution only works if the angles are equal, not supplementary. All right. Any questions, comments, concerns from you guys? Okay, here we go. Let's keep grinding. 2 more. Mark up your diagram for me. Mark it up. Now you got to start fresh. Statements, reasons. Make sure we got arrows on AD and FB, and we have arc marks on angle CDA and angle BFE. Make sure everything's labeled properly. Let you guys write everything in. All right, look at your proof statement for me. Don't mark it, obviously. We don't mark the proof statement. But I want you to see where those angles we're going to try to get congruent are. CDF, the big angle, with DFE, the other big angle. All right, there. The first given, AD parallel to FB. I told you that for a reason. I want you to look for those type of angles we talked yesterday. Alternate interior, corresponding, same side interior, same side exterior. Using AD and FB, using those 2 parallel lines, does anybody see any of those angles we have discussed yesterday? It has to involve AD and FB too, and a transversal they have in common. So AD and FB, anybody see any special angles? And again, when I say special angles, the one we talked about yesterday. Think you got some there for me, Bailey?
Yeah.
Take a stab at it. Who cares? If you're right or wrong.
ADF and DFB.
Stop right there. Okay. Here's the, let me just, so you guys can see what angles just gave me. This angle with, everyone see those? What angles did Bailey just give me? What types are those? Those are, here are my parallel lines. Are they inside or outside? Inside. Same side or alternate? Put them together. What did Bailey just give me? Alternate interior angles. Everyone see what you just gave me. And what do we know about them? Congruent or supplementary? Okay, whoa, wait. I just want to make a plan down before I start writing statements down. All right, so they're congruent. Wait, whoa! How am I going to get to the bigger angles then that I need to prove? What am I going to have to do to these together? Oh, this is an addition proof, isn't it? But wait, unit 2, I kept barking at everybody. If you're going to use addition, how many pairs of equal quantities do you need? 2, but in the givens, I only have 1 pair. Where's the other pair going to come from? The alternate interior Bailey just gave me. Okay, so everyone see this is an addition proof. Going. We sure? Ask questions here because this is not easy at first. So step 2 is going to be addition or no? What do I still have to write in? The alternate interior angles, right? So angle ADF congruent to DFB. What would I have you write yesterday? Here you go. Going back to the numbers here. 1, 2. Finley, what would I have you write yesterday? Why these were congruent? Excellent start. I like it. Keep going. Darn right. Whew. Perfect. And now in step 3, what am I going to do to those 2 pairs of angles I have congruent? Add them together. Okay? This is an addition proof. So angle CDA, I'll get out of your way here in a second. CDA plus, what am I going to add to CDA? ADF is equal to BFE plus, if I go BFE, a DFB. Hey kids, what unit are we in? 3? Still not changing. What's going to always happen next? Yeah, I promise you. I don't care if we're in unit 3 or in unit 10. After we use addition or subtraction, we're always going to use substitution to finish it up. Whew. We're going to keep using the theorems from unit 2. The only thing that's going to change, listen, the only thing that changes, or it doesn't even change, it's just in an addition here, are using the parallel lines to get special angles. That's it. Any questions before I move on to the last one? And then you're on your own, or I'm going to let you work with other people here. Oh boy, let's go. Okay, arrows, right? Okay. Anybody seen anything in the givens that might alert you to what this proof is going to be about? Not just one bisect. How many angles are we bisecting? 2. Automatic, probably. How do you guess this proof's going to end? I'm bisecting 2 angles. Halves of equal quantities. Yep. All right. Now look, and this is a definite. It's going to be halves of equal quantities. Look at the 2 angles. Look at the diagram. Everyone, look at your diagram. Look at the 2 angles I'm bisecting, JEB and EGD. Want to tell me any relation between those 2? Look at the 2 angles I'm about to bisect. JEB, find that on your diagram, and EGD. What do we call those 2 angles right there? Whoa, all right, we got it now. Yep, corresponding angles. Yes, yes. So what do we know about them? They are congruent. So first thing you need to tell me is whatever we're about to cut in half are congruent. JEB, congruent to EGD. You need to tell me whatever you're cutting in half are congruent to each other. What would be your reason here now? Ooh, come on. We used the justifications yesterday. Dylan, go. Good start. Good start. Yeah.
That corresponding angles are true.
Darn right. All right, let's see if we remember anything from Unit 2. Step 3 isn't going to be HGD and FEB are equal halves of equal quantity. I'm still missing something I didn't tell you. Anybody know what I still need to show before I say the halves of equal quantities are equal? Lexi, you think you got it?
You have to put like JDF and
You have to show that you're cutting them in half.
Right? Name one angle I'm cutting in half, Henry.
JEB.
Okay, here you go. Ready? I'm taking JEB and cutting it in half. And I'm calling it this new angle. So everyone, let's look at your diagram now. Look at JEB. I'm going to cut it in half. You have two options right now, right? You could call it JEF, or you could call it FEB. There's only one I'm really concerned with, though. Out of those two choices, which one do we want here? Why FEB? It's in the proof statement. You got it. And now tell me the other angle you're cutting in half. EGD. All right, look on your diagram. What would I want to call that angle now? I have two options again. Only one, though, for the purpose of this proof, is the one I want. HGD. What gives me the right to cut them in half? Because we're not ready for halves of equal quantities. That's how we're going to finish it. What gives me the right? What gave me the right somewhere in the proof that says you're cutting them in half? Dylan?
it says bisects.
Definition of bisects. Now, once you tell me you're cutting them in half, now you can set those new angles equal to each other. Halves of equal quantities are equal. So before I let you go and move around and work with whoever you'd like to work with, be prepared in every proof tonight to use the parallel lines to tell me certain angles are congruent or supplementary. All right, so I'll let you guys move around, work with whoever you'd like, because we got plenty.